think we can get started. Thanks for joining. Peter, a month off, and it feels like it's been forever now all of a sudden.
I know I was over in Australia doing the PCA training, and it just imperfectly timed up with my session. So I apologize for missing last month, and but at the same time, I'm kind of happy to be back to it, and it was fun to kind of provide that PCA training in Australia. So yeah, so it's kind of a fun sadness.
But we're
um,
back. It's all good.
we're
And we've
back.
got a new face with us too.
We do have a new face. I'm going to introduce him in a second.
Okay.
This webinar is an interesting one. We're going to talk about event connectivity in this webinar, and it's not easy to set up a lab environment and do my real-time demos. So I have brought the best thing I can think of for a lab, and that is Adam Stedman. And he runs Event Wi-Fi over in Europe and provides large-scale events. And actually, I have referenced him in several of my videos because of some of the amazing, I think it was 190 WANs. Was that right, Adam?
Okay, it was only 100 WANs.
100 WANs, okay.
Only.
But bonding 100 WANs. And so I brag about Adam often when I'm talking about the number of devices we can connect to an EPX. And so I'm really excited to bring him in on this, and he is my live demo. So we're going to talk together about event connectivity and some of the challenges associated to it, but some of the amazing capabilities that Peplink brings to the table. And so thank you, Adam, so much. If you want to give a few seconds just about yourself and what you've been doing.
Sure. Well, thanks very much for inviting me, Peter. It's absolutely brilliant to be involved in this little Peplink University webinar. So yes, you're right. I'm Adam from Event Wi-Fi, and there's no prizes for guessing what we do as a business. And it's no secret that we absolutely love the Peplink ecosystem. So I'm very happy to give you some insight into things that we do at events.
Excellent, thank you. And as always, Travis is with us, which is always fun to have this new trio here for this webinar. So basically the idea is we get told about there's a lot of challenges that are associated to event Wi-Fi. It's not like even what I do with mobility connectivity, it's not the same. You have diverse topology, you have various capabilities for connectivity and mounting, you have restrictions on what you might or might not be able to bring into the venue. So there's a lot of challenges that are even not mentioned in what we're going to talk about today. But one of the biggest challenges, if you assume that we're able to deploy a Peplink solution or a cellular solution or a Starlink solution, would be associated to congestion or capacity. And there's two areas that plays in a challenge. One, you've got to, if you're trying to serve the number of people that are using the Wi-Fi, but then also they are creating their own problem with all of their cellular devices. So you have this mix of 200,000 people in an event that are both causing congestion, but also trying to access a network. So you need a network that can scale to that size. And so the challenge is a lot more difficult in that scenario. And I mean, what's the biggest event that you've provided connectivity for, Adam?
I can't possibly tell you that. I have to keep some secrets. But no, you're right. I mean, the thing with high user density is there's two things to consider here. One is your incoming internet connection. So you're talking there about cellular, you're talking about what existing infrastructure is at the venue. How are we going to make use of those? But then you've also got the Wi-Fi side as well, and how we actually deliver that connectivity to the end users. And it's, you can analyze, you can always go and do testing, you can go testing before, but it's never going to be the same when you go to the actual event. So there's lots of scenarios you have to play through in your mind to work out what that's going to look like when you get that full density of people there. And I've lost Peter.
No, there was a complaint about my audio, so I was going to hook up my headset. Yep.
So yeah, I think being able to plan adequately before you go to an event is absolutely great. And there's another thing as well that you have to take into account is people tend to bring their own devices as well. And it's how do you manage people bringing their own Wi-Fi, their own, even mobile phones taking into the connectivity as well.
So
Give me
Andy, I'm
one
guessing
second,
that
Adam.
influx of-
I want to move on, but I got a complaint about my audio, so I just wanted to connect this headset real fast. I apologize.
I'll let you reconnect.
Yeah, give me just one
Adam,
second.
I thought that was interesting that you pinpointed two different aspects of the connectivity, and I'm guessing that that influx of users impacts both sides of that connectivity as well.
Absolutely.
So then the next challenge is uptime, and this one I do have a little bit of experience with because it's why I get called sometimes. But when you're doing, when you have an office setup or even a mobile health setup, you have protocols in place that might, hey, if my internet drops, switch to pen and paper or do something like that. When we're talking about live events, and this even goes to even church events and things like that. But when you talk about live events, you can't have a downtime. Downtime is simply not acceptable. There is no backup protocol in most scenarios when you're trying to live stream or when you're trying to host an event where content is being delivered. And so it's not like, oh yeah, we'll have a 24-hour response time. Great. Then that means the internet's been down for 24 hours. The event is now over and we lost it all. And so having the ability to have basically 100% connectivity is critical for event space and well, for real-time events.
Yeah, single point of failure is one of my big buzzwords. I always speak when I look at an event, I'm always looking at all the possible single points of failure. But you're right, an event happens today. There is no tomorrow in events. If it doesn't work today, it's too late.
Exactly.
It's not the same with the enterprise world or the corporate world. You can always say, oh, I'll order a part, it will come tomorrow. But you don't get that luxury with events. It has to work now. So it's about selecting the right hardware to make sure that you eliminate every single point of failure possible. I'm not saying you can eliminate every single point of failure. You can always find an edge case. But there becomes a point where how much do you spend on a project, depending on how much resilience do you need, and there'll be a balance between the two ultimately.
Yep. And I think it's also in that scenario, it's also risk assessment, right? If the percentage of an enterprise grade piece of equipment failing is 0.001, then it's like, okay, well, how much do you want to pay to mitigate that risk versus the risk of a cellular connection not working or an internet connection that might or might not provide enough bandwidth. I think there are scenarios where you can look at the cost or the opportunity of that risk occurring and then the cost to mitigate that risk, and we always going to balance that out.
Absolutely.
And then the third challenge that we see here is diverse locations and cellular performance. Events take place in a variety of locations, from urban centers to remote areas. So we need to requiring flexible connectivity solutions that can adapt to different environments. And so events happen all over the place, and they can happen in a metal building that has virtually no internet connectivity. It can happen at a convention center where they have nice just cellular repeaters and amplifiers, and and so you're really dealing with congestion, not necessarily signal strength. But the point is they can happen anywhere, and so we have to be able to adapt to those scenarios where what happens if there is no cellular, or the Starlink isn't available, or the venue internet is not even, it's just not physical. I once again, I deal with a lot of church events. So, they'll go out to the field and say, hey, we want to do an event out in this field. And there's no power, there's no venue internet there. So you're basically having to create that infrastructure live.
I do love a challenging location. I think probably the one of the most exciting ones we did was for a music streaming site, which was a nuclear bunker underground. I mean, that is quite a challenge to actually get connectivity in a nuclear bunker that's by its designed not to get any signals inside. Even through to, and there was some aircraft hangars where they developed Concorde the other week, and they were launching a car inside, racing around inside. But we always go to a blank canvas, and quite often there'll be no infrastructure there already, and it's building something from scratch. And that's quite exciting with events, to be able to do that, deliver it, and then celebrate that at the end when it actually works.
Well, and then for your job, it's always different. So you get to do this. I mean, every, a bunker. I mean, a bunker, the only thing I could think is we set up, a whole bunch of Starlinks and 5Gs outside, run fiber to IDFs inside, and then distribute the Wi-Fi network. Would that be?
I mean, on this particular scenario, there was a cellular tower right on top of the bunker, which was in a tower that was originally involved with some project they had going on there. So we had all the equipment outside, and we were able to aggregate all that cellular, aggregate all the other connectivity in there, and then run it inside the venue on fiber to access points dotted around. And one of the beauties of Peplink access points is you can run them on PoE, but you can also run them off DC as well. So it gives you the ability to be able to run them on battery, for example.
Yep.
And with an event, you're not looking at being able to have something running all the time. Your event may only last 12 hours. So you can create some very exciting solutions with the Peplink ecosystem.
So that would be fiber to like a 12 volt fiber to RJ45 transceiver, and then DC.
Absolutely.
Like and then just a little battery there.
You could do that, but you've got the even the Peplink switches you can run off DC, and those have fiber transceivers on them.
Oh, and then you wouldn't have PoE when you're doing 12 volt at least, so that you would have just 12 volt right into the AP.
We can run those switches. I think we can run those switches off 12 volts, can't we, Peter?
You can, yeah.
So you're doing that, and you can run the access points off 12 volts, and you can run all that off a little lithium battery, dumping those in places.
That's
so
awesome.
There's some interesting solutions. I mean, there was that new cable that Peplink's brought out recently, which allows you to power the new microfit devices off a battery.
Mm-hmm.
So there's some good solutions out there in the ecosystem.
I like it. And so speaking about solutions, that was a perfect segue into kind of how Peplink helps in that scenario. But one of the challenges that's not on here that I do want to hit before we do that, actually, is venue cost. When I go to like a trade show, I go to like NAB I don't want to say the trade show name. I go to a trade show, and it's like they have this internet there, but specifically if it's a large capacity venue, they'll charge you. I got a quote, $32,000 for 25 megabits per second of internet for 3 days. And
that's good. That's a good price.
It's so you go. So if I bought an MBX with 4 5G cards, my ROI is a day and a half. And then every future event is then free in its essence because of the cost of that. Is that in Europe? Is it similar, or are there?
Well, Europe, I mean, I won't lie. The cost of conference venue connectivity is very high. I wouldn't say it's quite as high as you've just said there. That was probably Vegas or somewhere like that.
It was in Vegas.
There you go. But it can be quite expensive. But a lot of the venues in the UK and Europe do have probably good enough cellular for what you need on a trade stand. Because quite often on a trade stand, you don't need an awful lot. And I mean, I wouldn't necessarily for us, I wouldn't say the MBX is necessarily our go-to product for something like that for a trade stand, but certainly things like transits, I absolutely love for that. Because a transit,
the BR2 is one of our most popular, but I mean, I am Professor P, so I have to have an MBX. I mean,
even the BR2 is a really good package for doing that. And again, you've got the party trick. Quite a lot of those conference venues will have Wi-Fi there, will have guest Wi-Fi. There's nothing to stop you connecting those devices to the guest Wi-Fi, doing a bit of speed fusion and connecting that to your cellular as well. And you've got 3 connections in your dual cellular box now.
Amen. Okay, so now we're going to go into the official solutions. I just wanted to bring that up because trade show event internet is ridiculously expensive. And I think that the solutions that we're bringing to the table here, it's like the idea of solving that problem, but then also potentially even saving a lot of, so it's like being able to complete your mission, but also saving a lot of money and over the course of even just one or two or three, if you do 2 events a year, as a like for trade shows and booths and things like that. But anyways, so when we talk about user density, Peplink can maximize accessible bandwidth by connecting multiple carriers together. And so we talk about the ability to use guest Wi-Fi, cellular, satellite, and venue Ethernet if they're going to provide it to you, and combining all those together to create as much capacity as possible. But I think when we talk about user density, there's also providing Wi-Fi, and you mentioned it a few seconds ago, but we talked about distributing Wi-Fi networks. So one is getting internet through congestion. The other is providing internet to a bunch of people. And I know like the AP1AX supports 256 users, but if you have 10,000 users, are you? I mean, I don't know what the largest you've done is, but are you mounting like distributed APs to cover zones of roaming, or how are you handling user density?
We do. I mean, there was an event we did recently, which was an old hall in the UK. We just put multiple access points in there. You've got to balance your frequencies up properly. We've got different frequencies to play with. Obviously, the 5 gigahertz is much better than the 2.4 for density and capacity. And most devices can use 5 gigahertz now. But another trick we use as well when balancing that Wi-Fi, have you used the Air Probe system available with Peplink?
I have.
So this is
brilliant. I didn't know very many people even use that anymore, but
well, I absolutely love it. So we will take maybe even some older Peplink devices that are still capable of doing dual band Wi-Fi and dump those in strategic places, and we can actually then monitor the frequencies and balance up the network that way as well. And that's available, I think, on every Peplink device that has Wi-Fi. You can just go into a special setting in there and turn it on.
So you have Air Monitor available on all Peplink devices that have Wi-Fi, but Air Probe is a special product.
Air Probe.
And that one actually has the spectrum analysis and things like that, whereas Air Monitor gives you the ability to monitor like Wi-Fi performance and rogue APs and things like that. Air Probe is a tool. It's an AC. It's basically an AC Mini, the old AC Mini, with a spectrum analyzer built into it. So it acts as and it gives you a lot more reporting to it.
But I think you can also turn that on devices like the Transit.
Air Monitor. You can turn on Air Monitor.
Air Monitor, not Air Probe.
Yeah, Air Probe and Air Monitor are a little bit different.
Little bit different, but it's good. It still gives us an awful lot of feedback for when we want to balance those things in a high density. But the range of Wi-Fi, I think, is also worth talking about as well, because you can't just put one access point in and hope it's going to cover an entire venue. And everybody will have a different distance that they want to work with. I work with about 25 meters from an access point before it becomes reliable. You can convert that to feet because we're European, so we're all in meters here. But you have to also accept that one access point could fail. So you've got to put your access points in a certain distribution around, so that if one fails, you've still got another 2 that could still cover that area for you.
Definitely.
Have I answered your questions about congestion?
I think we got it. So the idea is, but the point though is that not only are we trying to address internet capacity under congestion by monetize or by maximizing the opportunity of various diverse carriers, we also have to pay attention that when we're specifically talking about events, not just being a trade show booth, we're also trying to provide wireless to a bunch of people. And so you have 2 different areas that we're trying to solve when we talk about high density. But when we talk about cellular density, one of the cool things about Peplink when we talk about cellular capacity and there's kind of a fun little test question that Peplink does. It's like, if a tower has 100 megabits of throughput and you have 10 people on that tower, each person assuming they were using full capacity, is going to get, around 10 megabits of throughput at the same, if they're using it at the same time. And so the idea is if I'm two of those people, now I have 20 megabits of available throughput. And so when you think about tower capacity, you have a couple different ways to handle that. One, we can offer diversity of the carrier itself. So I'm connecting to T-Mobile, AT&T, or Orange. I think isn't Orange a European?
Vodafone, EE,
Yeah, Vodafone.
Free. Yeah.
So different. Anyways, you could have different carriers that you can diversify at maximizing tower access. Then you can be multiple people or multiple presence on each carrier. And so the ability to have, we do a lot of work with like T-Mobile SA right now in events, because they're doing like their some cool 5G technologies. And so we'll have a T-Mobile band 25, a T-Mobile band 41, a T-Mobile band 71. And so we'll have 3 T-Mobiles all set to different frequencies connecting at a venue, and then we bond those together. So we'll create, and then we'll have, 2 or 3 T-Mobile or AT&Ts, and then 2 or 3 Verizons, and we're combining all those together to, one, maximize the carrier diversity, 2, make sure we're getting the most bandwidth out of each frequency that those carriers provide. And so we're trying to make sure that there's enough. We're taking advantage of the all opportunity for connectivity there is.
Oh, you're so lucky to be able to test the 5G SA system at the moment, because it hasn't really. We've got O2 that's dabbling in it at the moment in the UK, but it's certainly not mainstream and won't be for a while. While we're talking about high user density, is it worth talking about traffic shaping and the ability of the newer firmware?
We have another slide for that. So we'll talk about traffic shaping. Yeah, we do. Yeah, we'll talk about traffic shaping in a few minutes.
Perfect.
So it's just more of how we handle high user density. So I got a whole slide dedicated to traffic shaping.
Little teaser for the future.
So if we talk about constant uptime, and so Peplink, because we can manage multiple internet connections at the same time, not only can we do traffic shaping, which we'll talk about, but we also have the ability to do hot failover. Hot failover is different than failover, and it's important to understand. If I'm at a venue and they're giving me a gig by gig circuit, and then I have Starlink or 5G, I might say, hey, look, this gig by gig circuit is enough to accomplish my needs. However, in the event that goes down, in the event that something happens, I need to transition to a bonded 5G or bonded 5G and Starlink solution instantaneously without interrupting the flow of data. And so Peplink has this ability to wrap that, what we call hot failover. It's a feature of Speed Fusion that basically says, hey, I'm going to use this gig. I've got my Speed Fusion VPN going to my Azure data center, wherever. And then I'm going to wrap that with I'm going to take that dedicated internet that's at the venue, and I'm going to wrap it with Speed Fusion. So in the event that's, as long as that gig by gig circuit is working, that's all I'm going to use. Never touch the 5G or the Starlink that has higher latency and things like that. Use that gig circuit. In the event that goes down, the 5G and the Starlink are sitting there ready to go. And literally the router can just move that traffic almost instantaneously to the 5G and Starlink service, giving what we call hot failover, session persistence over WAN failure, switching between WAN links. This is very, very different than having, some other product that maybe you have your gig line and then you have your 5G and you go, okay, in the event that this fails, now all my sessions break and it moves over to the 5G, and then everything gets reestablished over 5G. And so when we talk about needing this ultimate reliability at events, hot failover plays a really large role in that, especially if you have good venue internet that you're going to take advantage of, for your capacity, and then want to be able to have that resiliency going over to 5G and Starlink.
That's really good. I mean, when you talk about hot failure, what do you think about the drop-in mode as well on devices?
So because I'm a Peplink guy, I try to fight against the drop-in mode because, and I know that it makes sense. If people put in their, their third-party firewalls and routers and things like that, so you're going to drop in mode into that, and that about gives you the ability to have that hot failover. I've got a lot of customers that play around with other brand systems for their LAN network. I primarily focus on Peplink in my world. So yes, drop-in mode does play a role when you're trying to integrate with other platforms. But
it makes configuration very easy, because quite often we'll go to a venue and it may have a pre-existing internet connection, but by their own admission, they'll say it's not good enough for what we need. Can you do something quickly to beef it up? And something like drop-in mode can be very useful for that.
So you're saying at the venue side, adding hot failover to the venue's provided internet. So they have their own infrastructure in place and they go, hey, this isn't super reliable. So you'll throw, an SDX and drop-in mode or whatever with some 5G or domes or Starlink or whatever, and increase the resiliency of the venue internet provided to the entire network.
There you go. So they've already got their pre-existing infrastructure. They've got everything. We can just put a little bit of kit in there, and now we've given you that redundancy that you want. Because your single point of failure is your fixed line. It's brilliant, but it's a single point of failure. That's a very simple, quick, easy way to drop a bit of Peplink equipment in to get that resilience. There's still a failover time on that. It's still down to health checks, and I'd probably say health failover is a better. It recovers a lot quicker if there was an issue. But again, it comes down to budget and what you're trying to achieve at each venue and what they actually need. I
like that. I didn't even think about actually working with the venue. I'm always trying to fight against the venue.
If they've got a good line, you want to use it.
Definitely. Yeah. Definitely. That's a great use case in design. And then finally, diverse locations and cellular performance. Peplink's ecosystem ensures unmatched network resilience. The compact devices offer seamless deployment in almost any location. I am going to add the almost there, indoors or outdoors. And we will talk about that in the next slide a little bit with some use cases there. But I will say that we've had several customers that will buy the solution for, and once again, when I think events, primarily I'm dealing with trade shows. That's why I brought you in here, because you do really cool, large scale actual events. But we've had some incredible use cases where some pretty large companies were tired of paying those trade show fees. And so they wanted a robust solution that they could go almost to any event location and have connectivity and not pay for the event internet. That was their thing. Like, we don't want to pay the trade show internet. Wherever we go, we want to be able to set a box down, turn this thing on, and power our booth. And we don't want to have to think about the internet solution that's happening. We want 0-day connectivity. And so we taking advantage of high performance antennas, taking advantage of multi-cellular and diversity, even using like Starlink in some really rural areas. The complete ecosystem integration of cellular and Starlink and Wi-Fi and Ethernet allows you to basically take these devices anywhere, turn them on, and basically connect to anything you want. I've even had people tether their cell phones on the Ethernet ports and provide even more bandwidth. They'll maybe have like the Samsung S24 and they'll have that millimeter wave, and so they'll plug it in and have a millimeter wave internet circuit at some locations. And so the ability to basically connect any internet possible into these devices and then make the most use of them, and provides incredible robustness, kind of almost anywhere you go.
Yeah, I agree with you. And they're just so adaptable. There's so many different types of connections that you can put into these devices. The connections you can use are changing all the time. You mentioned Starlink there. We wouldn't have been speaking about Starlink a couple of years ago. There's other projects coming out which are using low Earth orbits. There's mid-Earth orbit. There'll probably be some other clever connectivity coming out soon. But Peplink's pretty future-proof and looking forward, very forward-thinking to actually roll up those into their single package. You're talking about trade shows. I'm going to mention a trade show we're doing as we speak, whereabouts we've got a load of dual cellular modems all up in the marquees all around the venue, and it is just purely running off dual cellular Peplink routers everywhere, and that's
Really?
providing enough capacity for the whole thing. It's in the middle of Scotland somewhere. Absolutely brilliant. And we're quite lucky that there's 2 cell towers really nearby, so we're getting really good bandwidth from those cell towers. And cell data is charged very differently in the UK to the States. I know we get gigabytes of data for next to nothing, whereabouts I know the data can be quite expensive in the States. But there's certain trade stands there as well that want to have their own dedicated connection. So we'll give them their own private Peplink bit of kit. So that's their dedicated connection using their cell. And then everybody else in the guest Wi-Fi are using this big array of Peplink dual cellular modems instead.
And how are you creating the array of dual cellular modems? Are you using Speed Fusion, doing like layer 2, or are you synergizing? Like,
we're doing a layer 2 network across there. They've got a captive portal, so they can all log on. But of course, you've got In Control, and In Control lets you manage all of that, manages all your frequencies. You're just treating it as a very exciting access point that's a totally modular system. And if a device has an issue and there's no internet connection, it'll drop it out of the array anyway, because there's no internet connection. It just takes that Wi-Fi out until it's recovered and brings the Wi-Fi back in again. So there's ways to build really exciting networks in lots of different ways based upon the tools that Peplink give you in their device.
that's genius. I like it. So, and hence why we brought in Adam.
Question for both of you guys, and I think this slide kind of segues nicely, but given all the different connectivity options there are today with all the different 5G providers, Starlink, how do you guys start to calculate that when you look at each event? And Peter, again, this goes to you as well. Like, where's that line drawn in terms of like, I need this many 5Gs, I need this many Starlinks? How do you start to evaluate that, what you would use in different scenarios?
Yeah, I mean, for me, I the first thing I do is ask what the mission is. It's the little 10 by 10 booth where you're trying to get on the internet and just check, have people register a form or stream a YouTube video, things like that. Or are you trying to do some live streaming with 4, 5, 1080p streams? Or so the first thing I ask is, what's the mission? I don't. A lot of people come to me and go, what's the maximum? What's the maximum? I go, if I tell you the maximum, you're going to be disappointed, and then it'll be a fail for me and a fail for you. So I try to avoid with maximums and go by, what is your mission? What are you trying to accomplish? Then from there, I try to set the expectation based on the average capacity of each carrier, not the maximum capacity of each carrier. Understanding that obviously it can range from 0, right? I mean, no service, all the way to several hundred megabits. And so the idea is, what is our average capacity or capability? What should we expect in general? And so, say 80% of the time on AT&T, you're going to receive, I'm making this up, by the way, 25 megabits of throughput, and so we're going to, and so it's like, is that good for you? And so does that make you meet your mission, for example? And so that's a lot of times, that's how I decide what level of connectivity the person might need is, what do we have access to? How can we maximize our opportunity? And then what is the most robust solution to accomplish the mission? And then I kind of double it. Because there's always variables that kick in. So, if they go, if a single 5G might almost always meet it, I'm gonna say, hey, why don't we go with dual 5G and just add that layer of protection? If a dual 5G works, hey, let's add a max adapter. Let's just add one additional, just to give us that tiny bit of variable, contingency in a sense. And so, because once again, when we're talking about live events and venues, failure is not an option. So we got to meet the budget that the customer has, but at the same time, understanding we need to make sure that I don't want you to come back to me and go, this thing sucked, right? That's not an option for me. And so, as much as I want to meet the budget, I also got to make sure that I'm guaranteeing the mission. And so that's sort of how I play in that world. And that's how I choose which router I recommend.
Yeah, I think a lot of it is about educating the customer. And I think there's been, in the past, a lot of people have had a bad experience with Wi-Fi and event Wi-Fi, and it hasn't worked, and there's been problems. So it is about setting those expectation levels and understanding exactly what they need. And they'll come with unrealistic things, saying we're doing a live stream in full HD, we need 100 megabits a second. And we're saying, well, you don't. By the time you've got your encoders, you need 5 to 6 megabits a second. So we'll look at the different types of traffic that they're doing on an event, and we might set up multiple networks. So we could have an MBX that handles the live stream side. We could have some BR2s that's handling the production Wi-Fi side, and we could have some SDXs with some access points that are then handling the public Wi-Fi, VIP Wi-Fi, guest Wi-Fi, that kind of thing. So it may not be one solution fits all, but you've got to look at what their requirement is and making sure that you're putting in the right hardware to meet each of those individual requirements.
That's interesting. It sounds like it's not always just a big monolithic network, right? You've got all these kind of little segmented networks sometimes, it sounds like, in your deployments as well, depending on where people are, I suppose.
Absolutely. I know I'm famous for creating this 100 WAN connection, but there is no use case for having 100 WANs on one EPX. But there you go. It's there's a point where it just gets silly.
But silly is sometimes fun.
It was very fun. And there's a new challenge coming soon. So watch this space in about a month's time. There'll be a version
Perfect.
2.
I'll be eagerly waiting. And actually, you brought us right into the next topic, Adam, with picking the hardware, and we kind of like, just in the essence of being able to share, kind of threw together 4 kind of sample solutions or sample packages where we're showing the kind of the opportunity or the capabilities that you could build with a Peplink solution. And so, the obviously my favorite is diversity. So on the smallest scale, you could do a transit or a BR1. But really, when we talk about meeting the needs of density, diversity, scale, I kind of wanted to start this at the BR2, because this lets us have two 5G carriers, and really the USB gives us a third potential, tether or millimeter wave solution as well. It gives, and then we have dual Ethernet. So you have the ability to have Starlink or Venue Ethernet connected to this, as well as dual Wi-Fi WAN, 2.4 and 5 gigahertz. And then it has its own Wi-Fi LAN capabilities as well. And so when you look at like the BR2 as a small scale, and once again, I kind of think of this as more of a small event or a trade show. But we have this BR2 solution that has incredible robustness. One of the things I do want to say is, when you're sharing WAN and LAN, you are sacrificing some performance. If the radio is connecting to a WAN and then handing off a LAN, that radio is doing 2 tasks and it's being shared. And so you should assume that 50% of your capacity is being split between WAN and LAN. So a lot of times I'll recommend to people, use the 2.4 gigahertz and connect to the WAN, and then broadcast to 5 gigahertz for your smaller area that you're trying to connect to. That way, the 2.4 gigahertz is dedicated frequency. The performance of that is dedicated to WAN. And then on the LAN, we have our 5 gigahertz, or vice versa, whatever works for you. I'm going to put in mind, and then I'll let you then comment on these as well, Adam. But and then going up into more of the mid scale, the idea with the HD4 MBX having 4 5G modems. This is for me, this is the most popular router we've ever sold. Starting with the HD4 LTE, going into the HD4 MBX LTEA, and now the HD4 MBX 5GN with the new X62 chipset and SA capabilities. The product has stood the test of time. It's proven successful over and over and over again. And so a lot of times I'll say, where the BR2 might work, 90% of the time, the HD4 MBX is going to work, maybe that 99% of the time. Is that 1% where you're in the middle of a field with nothing, assuming there's no Starlink. And you just literally, there's no connectivity, so nothing would work. But having the dedicated dual rate modems, dual Wi-Fi modems, 3 Ethernet WANs, 2 USB WANs. So once again, plugging in those millimeter wave adapters or your cell phones or something like that, 4 built-in 5GN modems, PoE, so you can extend Wi-Fi. And I'm kind of merging these two here, but you can add Wi-Fi access points via PoE to this, you can then connect to the venue Ethernet. So it's like the MBX platform gives you the ability to have 3 Starlinks, 4 5G modems, venue Ethernet, venue Wi-Fi, and 8 PoE plus ports for Wi-Fi devices, cameras, etc., making it an incredibly robust mid-scale, mid-size event capability. And I believe the MBX supports 500 users. So we're talking about event user capacity. And then we're going to go to the SDX Pro, supporting 12 and 24 gigabits of stateful throughput. And I've actually put 16 domes on one SDX Pro before. So up to 16 domes, and I'll talk about what makes those really neat. Starlink, venue Ethernet, and then having, especially if you go down to like a switch with the 10 gigabit SFPs, being able to have, up to 2,000 users on an SDX network, or being able to combine a whole bunch of internet connections. The domes particularly are really cool because sometimes you're in a venue where you have, there's no cellular inside. You want to take advantage of the 5G or the cellular, but you're not getting that inside. So you can run Ethernet, Ethernet or fiber, go outside, have a switch, or just run the Ethernet up to 300 feet, plug the domes outside, have your router inside, and extend the infrastructure and maximizing 5G capability. So if you need those in that cellular connection outside, but having the router and the infrastructure inside, you can use the domes to do that. And it's a great way to extend the infrastructure. And if you're doing Starlink as well, you'd have 2 or 3 Starlinks outside, 3 or 4 domes outside, and then bonding all of that together to create an incredibly reliable, high performance network. Okay, I'll let you throw in your 2 cents, Adam.
Oh, you ready?
Yeah.
BR2, I'm with you. BR2 Pro is such a powerhouse. It's such a diverse beast. The amount it can do is just amazing, and especially when you look at the price point as well. Very, very powerful solution. I also love the fact you can power it off PoE as well. So that gives you the dual power option on there. The MBX isn't as popular in the UK and Europe. We like the MBX for live broadcast. I think it's absolutely brilliant for live stream, live broadcast and things like that. But the biggest failure in the UK, I would say, is cellular signal and things like that. So to have that device inside at a venue and then being able to get the cellular signal from outside can sometimes be a challenge. So you end up putting high gain antennas and things like that on it. So it doesn't necessarily make sense in the kind of oldie buildings that we have in the UK. We all have castles and drink tea and everything. It can be a challenge. The SDX, with you totally. I think this is a brilliant one for large scale events. The fact you can put these domes outside, because those you can get a module, can't you, that goes in there that gives PoE out. The SDX lets you have 1 bank of 8, and the SDX Pro lets you have 2 banks of 8. So that's what you get your 16 domes outside from. Of course, you've got the Dome Duo now. So,
well, you have the Dome Duo. We don't.
Do you not have the Dome Duo yet? Oh,
no.
Have you got the long range dome as well?
I have the long range. So we get the dome up the long range, but I do have a Dome Duo. I'm actually making a video on it. But it's European only right now.
It's brilliant, especially with that new the new modem that you're talking about, which not only lets you bond the 5G SA connections, but does carrier aggregation, the high frequencies and low frequencies, so we get more capacity. But yeah, I like that. And again, I'm looking at single points of failure. So would I have 1 SDX or would I have 2 SDXs? Because what happens if that SDX fails? You need to be able to use both. So
exactly,
but it all comes down to cost. You've got to look at what your individual scenario is and what makes sense.
And technically, you could buy 2 SDXs for cheaper than an MBX. So
yes,
you're talking about
2 SDX, you can do that.
So
we're talking about
HA
mode that we can do on there, which is another party trick. High availability, drop in. Yeah. I do like the SDX. I also like the fact you can side load virtual machines on there as well and other things. So
what kind of software do you run on that?
Not Peplink software. Be quiet. We used to run a little OS on there which let us do the traffic shaping, which is why I was
Oh,
speaking
okay.
about traffic shaping earlier, because sometimes we wanted to restrict how much speed a certain VLAN had or how much connected speed something else had. And the Peplink initially could only do 3 different rules for traffic
Yep.
shaping. I think that's
And
been
now we have,
increased to 10 rules now, hasn't it?
yeah, we have 10 roles now. With 8.4 firmware, we have 10 now.
And there's nothing, I mean, 10 rules is a lot for an event. And that pretty much
Yeah.
covers off all the scenarios that you would want. So that's been a bit of a game changer for us. So we're not sideloading a different firmware on there to manage that anymore.
And we actually implemented that for the for the cruise ship industry. There was a major demand for being able to manage. I mean, internet out at sea is incredibly challenging, and so we needed to be able to have more than 3 role groups to be able to for the different performance areas that each crew and staff and kind of the free Wi-Fi and the expensive different tiers of Wi-Fi that they wanted to be able to provide. And so we needed more than 10 roles there to be able to do that. And even though other verticals have asked for it like many times over the years, it finally took the cruise industry to really push it, where it's it was like this is like a hard requirement that we have to have more than 3 roles to be able to manage that.
That's brilliant. Well, we thank them for that. That's brilliant.
Exactly. And then kind of going in, I wanted to talk about load balancing and bonding and when to use them, but also traffic shaping. And so, Peplink, it's a common question that we get is, oh, I'm bonding, but it's not working. Well, did you set it up? And so that goes into what Adam was talking about with traffic shaping. And so Peplink uses outbound policies. If you think the word traffic shaping or traffic control, we call that outbound policies. And it's important that with any solution, you're making sure that the policies are set up to use the solution. The default solution is just kind of Peplink's auto algorithm, which is going to load balance the best it can across all your circuits. That doesn't necessarily mean it's the right solution for your needs. And so we have load balancing and bonding, and then we have traffic shaping and QoS and things like that. We probably don't have enough time. I think 5 or 6 months ago, we had an outbound policy, a dedicated video just on outbound policies. So if you go back to the Peplink University library on Peplink, but I do want to hit up load balancing bonding as it relates to events, because it matters, especially when we talk about density. If you have 3,000 or 4,000 people trying to share internet, and we take the fact that bonding has an 18% overhead, you actually aren't maximizing the total capacity by bonding all traffic for hundreds or thousands of users over that tunnel. Sometimes it's best to let them use each internet circuit to its fullest, and then bonding and adding QoS to critical applications like your live streaming or your messaging protocols, Teams and Zoom and things like that. And so the idea is you bond the critical infrastructure, the critical applications, and then you load balance. So split tunnel, right? We load balance the regular internet traffic. So if someone's swiping through Instagram, hey, if that's going to go on cellular 1, and then the next time they load a picture, that's going to be strung on cellular 2 or Starlink 1 and Starlink 2, and then event Wi-Fi or event internet. You don't need to have 3 gigabits of throughput for someone to scroll their Instagram feed, right? They just need to be able to query that and then load it fast. And so the idea is by using load balancing, you can handle a lot of sessions distributed nicely over all available internet connections. But then you want to make sure that, hey, FaceTime and Zoom and Teams and my live streaming application, those get bonded, and they traverse all of the internet connections to make sure that those packets get delivered well and efficiently, and then maintain a nice experience for the end user.
Yeah, I think when we're looking at events, you're right. There's two different types of traffic on events. There's stuff which is absolute critical and must work. So we're talking about things like live streaming. We're talking about payment gateways because a lot of events now have cashless payments, and those payments have to be taken. That's how they're going to make money on the bar, make money on the food stalls and things like that. You've got ticket scanning. So these are getting people into your venue. That's got to work. So all those kinds of traffic should be using some kind of bonding technology to make sure that packet of data gets through reliably. But then when you're there, you're then looking at giving higher capacities of data, which may not be as critical. You know, the fact that your Facebook page might take a few seconds to upload a photo or something doesn't really matter in the grand scheme of things. And that's where we look at load balancing that kind of connectivity and making good use of that. But there's nothing to stop you switching partway through an event as well. So it could be, as I said, you might be scanning everybody in on your bonded connection. You might be doing a live stream. That then finishes. We can then feed what we're doing with there back into the main mix, back into that load balancing to give you that more capacity again. And there's plenty of algorithms in the load balancing. Again, it depends on what your scenario is, whether you're trying to split the traffic, whether you're trying to have lowest latency, but that's all built into those rules and you can choose what you want to do. But it is understanding, again, what those requirements is for that event and what the customer actually needs and helping them through that journey to make sure that we build that network to their needs.
I think one thing that's really struck me as you two have talked through this conversation is this concept of risk management and single points of failure. And you guys have stepped through how you apply that in a lot of different ways, right? On the WAN side, there's, risks and different trade-offs there, just on the hardware side. But I think what you guys are talking about right now is actually applying that same process to the specific types of traffic that the users are going to be engaging in and applying that same risk management perspective there. And I think that's a unique aspect that you don't really hear about when you look at event Wi-Fi, right? And so it's interesting you guys are taking that engineering to, I think, a whole nother level that most providers don't really look at. It's just, do I have my internet connections and do I have my Wi-Fi there? And yeah, there's a whole nother layer that needs to be addressed, it sounds like.
Absolutely. We can't just turn it off and back on again at events.
I've had a few questions about firewalls, so I'm going to answer those real fast, even though it's sort of off topic. Peplink, I do have an entire webinar just on firewall, and we have another webinar just on outbound policies. So if you want to learn about those, I highly advise you go to youtube.com/Peplink and go to Peplink University and watch the outbound policy or the traffic shaping webinar, as well as the firewall webinar, because that'll answer a lot of your questions associated to Link's firewall capabilities and what we offer. There's too much there to try to unpack during this event, but I highly advise that you go watch those videos. So I just wanted to address that because we had a couple people talk about it.
I want to put one question back to both of you, and I think you guys have touched on it a little bit, but Adam, as you described, there's the WAN side and then there's the Wi-Fi side. And I think the Peplink's value proposition on the WAN side is basically obvious, right? We're the only ones that do speed fusion, bonding technologies, all the 5G and the Starlink integration. There's so many different things that we can talk about on the WAN side that makes Peplink the obvious choice there. But you two are both very sophisticated network engineers and have a long career in the field, and you're both choosing Peplink on the Wi-Fi side as well. And I think that one's pretty interesting because on the surface, Wi-Fi is kind of a commodity thing, right? Lots of companies make Wi-Fi access points. There's more popular choices for Wi-Fi. And you folks obviously have the choice to choose those as well, but you're choosing Peplink and you're doing that for a reason. And so I'm curious if you can just more focused dig into why you're choosing Peplink for the Wi-Fi side of this, for these large scale, critical, high density events.
I can say for me, it's I'm addicted to the ecosystem, Travis. Peplink has done an amazing job making it so that I can manage tens of thousands of customers from my cell phone. And that's so critically important for my scale, for user experience, and for deploying just the number of networks that we're now deploying on a weekly basis at this point. And so it's like there are lots of Wi-Fi solutions. There's lots of LAN solutions. I mean, I got people that are using different LAN switches and different LAN Wi-Fi networks, and they're going to stand by those. They're hardcore, and I support that. You want to throw whatever brand it is that you want to throw in the network, that's fine. I'm going to work with you. We can do OSPF, BGP. We can static route to you. We can just trunk VLANs down to you. So we can work with any solution. However, when we talk about Peplink and in control and the ability to go, okay, I need to create an SSID that's a guest network that reroutes a captive portal that's on VLAN 66 that trunks down through 7 switches. And I go, okay, add VLAN 66, apply this to the switches and the router. And then when I add that VLAN, make it this IP address and have the DHCP scope to be this DHCP scope. I hit save and apply and in control. And that gets pushed out to all the switches in the network as well as the router. Then I go to the SSID and I say, create this Wi-Fi network and have it go on VLAN 66. And I'm done. I just programmed a Wi-Fi network on 800 APs to traverse 6 different switches, or that many APs. So 20 different switches. And it worked in a matter of milliseconds. It's like, boom, done. And so for me, I will trade off some of those arguably better features, which once again, I'm gonna say arguably better features, in exchange for that unified ecosystem to be able to manage just the number of devices and user scenarios that we handle every single day. And so, and then not to mention the support. There's a lot of guys out there that will complain, talk about other brands, but I mean, the ability to just call you up and say, hey, Travis, I got a question. Have you ever done this? Or reach out to like the partner network and be able to get support. Having people like Adam and Martin Langrid and, these amazing people that are providing incredible insight all over the world. And so we have amazing support and a unified ecosystem. And I'm addicted to that package. And then it performs well. The Wi-Fi 6 products and the PoE products, the switches, they perform well. So you're not sacrificing performance for it, and I get ecosystem and support. So for me, that total package that just is such a lifesaver for our growth.
I couldn't put it better myself, really, Peter. You're quite right. The most important thing that Peplink has is in control, and for us, from a support side, it means that everyone in my organization works the same. Everyone in Peplink works the same. It's really easy to support. It even goes down to the point I can give my customers access to in control as well, and they can manage certain things themselves. It forces us all to use Peplink in a very similar sort of way, which you don't get with other ecosystems. Everyone's got their own way of doing stuff, and it can be hard to work out how to change this and how to do this. But Peplink makes it all very easy from that simple in control interface.
I think that's, sometimes it's the simplest things. And like Peter, you said, just pushing out an SSID when you've got, let's just say 8 different models of Peplink equipment out there between BR2 Pros and Wi-Fi access points, to just create one simple policy and configure all those different types of devices. That's unique. That's actually very uncommon to find. Usually vendors, it's all like one model at a time, and that zero touch provisioning concept falls apart quickly when you actually go to deploy it in real world scenarios. But yeah, again, it's just interesting to see both of you folks coming to that conclusion, and in scenarios where the performance really does matter too, right? So yeah, it's cool to hear that.
At my house, I have an AP1 rugged in my garage. I have AP1 AXs downstairs and upstairs. And then I have flex APs mounted to trees, kind of covering my backyard. And 2 of them are running different firmware because they're older hardware, but it serves the purpose. It's fine. And, AC Wi-Fi out, covering the land is fine. And I can program my SSID, set up my fast transition, And if we have an event, like sometimes we'll host events at our house, I can create a guest network, put a little capture portal with the event logo, boom, done. And the network's now operating with that, and we share it out with a little QR code or whatever, and people can scan and join in. And so, like, and you're right, it doesn't matter. Like it doesn't have to be the same devices. I could just zero touch that entire SSID solution with the VLANs and the captive portals and everything instantaneously. And it's so powerful. And so, I think we're at time. I tried to address most questions. Yeah, so if you go to youtube.com/Peplink, and then there's a Peplink University playlist. And then also youtube.com/West Networks LLC, we have a Peplink University playlist that has additional content outside of just the webinars. So if you're looking for Peplink University content, there you can kind of go to both locations. And then Travis, thanks for the questions. Adam, I'm so grateful you took out. I mean, I know it's after hours for you. Thank you so much for taking time out of your day to attend this and be my live demo, because I didn't know how to demo this, and you joined at last minute. I'm very appreciative for your time and knowledge.
Absolute pleasure, Peter. Anytime.
Yes, thank you, Adam. Thank you, Peter, and thank you everybody for joining us. This is another great webinar, and looking forward to the next one here.
And if you have any suggestions on webinar topics, please email travis@peplink.com or peter at westnetworks.com. If you have additional questions, you can also reach out to either one of us, and we'll get you in contact with whoever it is. So it doesn't matter which region you're in, we can get you connected to the right partner at the right region, and get you those answers, those questions answered. So if we did not answer your question, please reach out and let us know, and we'll get you to the right answers. So thank you, Travis, always for hosting.
Absolutely. All right. Cheers, folks. Adam,
have a good one.
Good evening.
Thank you. Goodbye all.
All right. Goodbye.